Howdy folks, hope you're doing well today. So we're going to be talking about some authentication and secure websites. So the first thing you might have noticed is that when we run our applications, we don't really connect to anything secure. Let me bring this down here. So this is just plain HTTP connection. There's no secure connection here. So you don't want to be sending any sort of sensitive information across unsecured connections. That's just bad form here. We could, if we wanted to, use the secure connection. So remember we changed port 80, or at least I had to 5080. The secure port is port 443. So in here I could go to HTTPS //localhost, and now my browser is going to say, hey, it's not secure. That was no, oh, I'm sorry, not 5080. There we go. And now it says, hey, it's not private. Someone from localhost might be trying to steal your information. The cert is invalid here. So I have a localhost certificate, but we don't trust it. We don't think it's a valid certificate here. So I could go take a look at my certificate here. This is just my localhost certificate. So this is just a generated one. Look, it's not even valid anymore. This is just an old one. It's been hanging out forever. So it's not a secure connection here. Now we could go advanced and continue anyway. They don't recommend it. And then like, hey, it's not actually secure because we don't trust the certificate. So if you go to like Google, just google.com, notice we're going to a secure site here. And we could go look at their certificate if we wanted to. So it's saying, hey, this is the certificate. And now there's a certificate path. So this is star.google.com is issued by this GTS, issued by this, issued by the Global Sign Root Certificate Authority. So at some point, our computer trusts this Global Sign Root Certificate Authority. There's actually a list of certificate authorities that we trust to issue certificates. But, you know, that being said, we trust that the owner of this certificate, if you have access to it here, is who they say they are. Now, just because there's a certificate doesn't mean it's not a malicious website, right? You can have certificates on malicious websites and you just happen to have encrypted traffic. So the way that all of this works, it's usually known as SSL, but it really is TLS, a transport layer security. It's super cool. Let me fire up Word here real quick. And I'm going to break out my handy dandy stylus because this is pretty fun. And I think this will work for me. I can't remember which way I have to hold this. Up or down, one of these directions here. And we'll see if we can go into drawing mode. Close this down. All right, let's see. Yep, there we go. So when we are first going to send a request out, we go to draw here. I don't think we want to do red. We do light blue. That's got to be fun, right? Try some light blue. So our computer here, right, sends a request out to the server. This is some web server here. And it says, hey, please give me something. We want it secure. So that's HTTPS. Still getting used to drawing with this tablet a little bit here. So what it happens is we send a request back here from the server, and the server is going to say, oh, okay, here's my certificate. So here's my cert. Okay, so we can get what their certificate is. Then what we're going to do, so certificates are based on this public and private key. Public and private key. That's supposed to be a P. That's not the right thing there. We're back to pen. Okay, and private. There we go. Told you I'm still working on this, but we'll figure it out. So the public key is known publicly. So everyone can get the public key. That's the cert that we looked at here. What the private key is it lets you decrypt information encrypted with the public key. So this is known as asymmetric. Asymmetric encryption. So the public key can be decrypted with the private key. And what that also means, you can take the private key and encrypt something that can only be decrypted with the public key. So our computer then takes the certificate and says, okay, sure, let me take some information here, and I'm going to send it over to you, again, encrypted here. So it's encrypted. And only someone who owns the certificate can decrypt it. Okay, cool. So if we can decrypt it, then we must have access to the certificate. Again, we trust that you should only have access to it if you should, but it's possible you can steal people's keys and things. And then the owner will send something back that, so this is encrypted with the public key. The owner will send something that is encrypted with the private key. and only someone who has the private key can encrypt with that, and then we can use the public key to decrypt it. So we negotiate here a session encryption. Now, this is important because the session encryption is not asymmetric. This is a symmetric encryption here because that is faster. So symmetric encryption works a lot faster than asymmetric because the math is a lot easier. The asymmetric encryption math is actually kind of crazy here, but you can go, if you want to go look up, here's Google here. So let's go look up the Rsa Encryption. So this came up by 3 math PhDs. What are their names here? That's the wrong link. Well, this one here. Wikipedia is better. Revest, Shamir, and Edelman came up with this system, and it's all based on math, which is super cool. So you take 2 really, really, really big prime numbers here, and you can do this math with them, and then you can get math if you reverse it the other way. And all sorts of funny things here. But we take prime numbers that are large enough to fit in, what was Google's key size here? So if you take a look at their key size, their certificate, this is a where is it here? It's somewhere in here. It tells us what it is. How many? What am I looking for here? One of these attributes. I thought it told us somewhere in here. Issuer, valid, subject, public. Somewhere in here is how many bytes it is. Key usage, no? Really thought we had somewhere in here the number of bytes. So usually there's something like 1024. I don't think it's only 256. That seems like that would be wrong here. But generally, your certificate. Let's try Bing. I think we can see that on theirs. Let's try their certificate here. There we go. So this key is 2048 bits. Oh, maybe it was. Wow, that'd be really small for Google. I'd be surprised. But for Bing certificate, 2048 bits. That means there are 2 prime numbers up to 2048 bits in size, which are really, really, really big. So 2 to the 2048 here is a number with 616 decimal places. Right, so if we look, like, how many primes are there? How many primes in a bit number? Let's see. How many bits does the prime number have? I think this is one we want. Let's see. If we get larger, yeah, so this, okay, so 2 1024 bits, still really large here. And those are some large numbers. Some really big numbers here. Like, I don't even know. That's more than a Google, right? That's more than 100 digits, I'm pretty sure. It's pretty large. So we deal with some pretty large numbers here. And it's just any 2 prime numbers there. There's tons and tons of them available, which is pretty cool. So anyway, going down that rabbit hole, the connections are secured using the asymmetric encryption to negotiate the symmetric session encryption here. All that is more than you really wanted to know. But again, you can get into web server administration if you're so curious, do those sorts of things. But getting a certificate says that you should have access to this domain. Again, we hope that people do it correctly and they trust it properly and all those sorts of good things here. But generally, the traffic will be secured, and you can assume only the person who has access to the private key can decrypt it. All right, so that is secure communications, how that all works. So what we can do then, if we wanted to, we could then function only for HTTPS connections. Sure, we could do that in PHP. You can do that on the web server side generally as well. Or just don't have, I guess most people want to have the non-HTTPS connection available, and they just redirect. I'm not going to bother recreating that. You can go look in the book. It's a pretty quick redirect here. But what that means then is now we can offer a way to log in. So I'm going to add a new controller here, a new PHP file. This will be our controller for the login controller. So the idea with the login controller is we want to log the user in, right? So we want to be able to see, okay, you gave me the username, you gave me the password, let's see if you did it right. So that means we're going to have to store someone's password in the database. And what we're actually going to do is not store their password. We're going to do another cool cryptographic thing, which is called a hash. So generally with encryption, the goal is being able to encrypt something so you can decrypt it later to read it. Right? So you need to be able to read the original. With a hash, it is a one-way encryption, and encryption is kind of the wrong word there, but it means you cannot get back to the original. There's no mathematical method of taking a hash and getting back to the original. Now, that doesn't mean it's impossible, but what that means is you have to try every single possible combination and see if the hashes match to see what the original was. So you can't go from the hash and get back to the original. But if you know how someone hashes, you know what the mathematical formula is, you can just hash everything. They'll call that a rainbow table attack, and just see which one does match eventually. So there's some other cool things you can do with hashing. You can add in salts and other random values and add in other things, or hash multiple times, and all sorts of cool nonsense to secure that. Go take a security class if you're interested. Again, we're going to focus on the development side here. But what we want to get then is a way for the user to log in. So let me actually go and add a view here as well. So this will be my login view. And in the login view, we will have our form. Let me go copy another form out from one of these here, because I hate writing forms. Sure. Here's a form. This will be our login form. Go to the login. So this is, we'll say login here. We want to send it to the login controller with a post. We want a, let's go with email address and password. And if you have a input type of password, it's actually going to hide it for you, which is really cool. And then we don't need any hidden inputs, so we just need a login button here. So for now, the controller should probably just include the view. Let me go grab that, make sure we're doing all this one right. Yeah, include the views of the login view. That way we're going to get the login page. This is just to start. And then let's, after that, after we include, or maybe before we include the view, let's see if we can't get those values out here. So just for fun, we'll try and get the email address. So we'll have an email address is, you know, we did this over here, didn't we? Yeah, I want to copy paste all that. Email address, here's our login controller, and the password. Now, we don't want to do this HTML special characters thing, because you can put special characters in your passwords, and that would be okay. So I think we can avoid the special characters. You know, it probably won't hurt. Let's leave it in here, because we're going to be displaying it here in a second, just for fun. And we'll get the password. So if you send me an email address and a password, we'll take the email address and password and throw those in here. And then we'll include the view. We just want to see the information here for a minute and see if we can't get that up and running. So we'll go to our top nav. We'll add a login here. So we'll have home, and then we'll add a login. Did I not have these non-breaking spaces? Should have had some more of those. We'll do a login. Login. Okay, cool. So we give it a run. We'll go to our login page. Grab that, bring that down here. Our login page has an email address and password. Try one at opencc.edu. We'll put in test. Now, as the type of password, it recognizes and won't show the characters, but gives me the little reveal button, which is nice. So you can see what it is if you want. I do login, and we send it back to the login controller. Oops, I grabbed them and never echoed them. Let's go back, and then we'll just echo email address, and password. All right, we just want to see if those ones show up for us here, and give that a save. I can probably refresh. It will continue, and we see the information came through. This is bad form doing it in an unsecure connection, but again, for our purposes, we don't really care. We're not going to go get a certificate that will get rid of that error here, so it's okay for now. Just know that that's bad. Okay, and the next thing we want to do is we want to convert their password to that hash. So anytime you're dealing with someone's password, you never want to use the actual password. You always want to use a hash, especially if you're going to store it somewhere in a database. So what we want to do then is we want to get a password hash. To get that, there's a built-in function. It's called password hash. Password hash, and then we can give it the password string here. Then if you want to, you can give it, what is it, the default. So you can be either a default option or a specific version here. Default's a little risky here because if PHP decides to change that down the road, we have to do some sort of migration. So, being specific about it and using this bcrypt, sure, you could if you wanted. For our purposes, we're just going to take the easy route here and, acknowledge that that is a problem for later here. And then we'll echo out the password hash as well. So we'll echo a line break and the password hash, and we'll get the password hash here. Okay, and then we'll give that a run. All right, and actually, let me just come back here and do it again. And test. Oh, goodness. Uh-oh. Password hash, yep. Oh, okay, so I'm sorry. I do need to give it the default here. Password default. Okay, we'll use password default here. Let me give that a refresh. There we go. No, oh, look, it seems to need to translate it here. So this is the hashed version of that password for password test. So I'm going to write that down here. Just save it in a notepad for a second here. Okay, so if I refresh, notice it's changing here. Not now. Because it's doing some automatic salting, which is really cool. That way of adding some information to it so that I can't just say, oh, I know that the function for password hashing is, let me just run through all the common passwords and see if I find one that matches. So I wouldn't be able to do that because it's changing every time here, which is pretty crazy that it can do that, but that's really neat. The next thing you can do here is you can ask PHP to see if the password is valid. So you can give it the password and the hash you were given to see if it matches. So what we're going to do, we're going to come to our database here. Let me open up phpMyAdmin, start MySQL. Oh dear. MySQL shut down. That's a lot of fun. So we'll come back to that in the next video then. But we'll be able to get their password hash from the database and see if it's valid. So we'll do that in the next video here. Thanks, folks.